Good evening, ladies and gentlemen. Let's look at some examples that will help us with the assignment from the Orange Book 5.4. We're only going to concentrate today on the problems 41 through 48. I'm going to start off by giving you an example for number 45 and 46. What we're going to do today is find some area using definite integrals. Okay, so here's example number 1. Let's find the area bounded by the x-axis in the graph of the piecewise function in quadrant 1. And for all of these problems today, it's going to be okay to use your graphing calculator to find the graph if the graph is not given. In 45, 46, 47, 48, the graph is given, so you will not need your graphing calculator. Keep in mind you could use your graphing calculator to find the definite integrals, but we do need to review the analytical work finding the definite integrals, so let's use our analytical work to find these. So example number 1, this piecewise function x cubed from 0 to 2 and from negative 4x plus 16 from 2 to 4. Let's look at that graph. So here I have y equals x cubed from 0 to 2, and I have the graph of the line y equals negative 4x plus 16 from 2 to 4. To find that, with or without a calculator, to find that area, what I'm going to need to do is I'm going to need to write two definite integrals. One definite integral that uses y equals x cubed, another definite integral that uses negative 4x plus 16. So this total area here, and it is in quadrant 1, it's the shaded black area, is going to be given by this particular definite integral from 0 to 2 x cubed dx plus the definite integral from 2 to 4 of negative 4x plus 16. And we did learn before Christmas that if a function is above the x-axis, the definite integral represents area. And that's what I'm looking at. A function that's above the x-axis over here. It is above the x-axis, so I can find this definite integral to find the area. Use definite integrals to find the area. So the first thing I'm going to do, and I may go through this analytical work a bit quick. If I do, keep in mind you can always re-watch the video or pause the video at any time. So the first thing I'm going to do is I'm going to find the indefinite integral for x cubed dx. Simple. Add 1 to the 3, I get x to the 4th, and divide by the 1/4. So the indefinite integral of x cubed dx is 1/4 x to the 4th plus c. Now I'm going to find this indefinite integral of negative 4x plus 16. Again, this is a fairly straightforward one. I take 1 and add it to the exponent of 1. 1 plus 1 is 2, divided by 2. What do I differentiate to get 16? 16x plus c. Keep in mind, I'm only going to use the part without the c to evaluate the definite integral by the fundamental theorem of calculus. So therefore, this area here, this rascal right here, is equal to 1/4 x to the 4th from 0 to 2. I have my evaluation bar. This portion represents this portion. And then I have, what I've done here is I have simplified negative 4x squared over 2, which becomes negative 2x squared plus 16x from 2 to 4. And this portion right here is this definite integral here. So I have two different definite integrals. I'm using the fundamental theorem of calculus twice. And what I would ask that you would do at this point is just look at this carefully What I'm going to do is put 2 into 1/4 x to the 4th. Is this portion right here. This is putting the 2 in. And then I'm going to put the 0 in. That's going to be kind of nice because this whole term is going to 0 out. And then I'm going to put the 4 into this right here. That's where I get this portion. I have a big bracket because I'm going to subtract this indefinite integral evaluated at 2. So I have 4 terms here. This term is really easy. It zeroes out. 2 to the 4th is 16 divided by 4 is 4. I will let you do the arithmetic here. If you need to pause, that's okay. Negative 4 squared is 16. Times negative 2 is negative 32. 16 times 4 is 64. Minus big bracket. 2 squared is 4 times negative 2 is negative 8. 16 times 2 is 32. You may want to check my arithmetic. This is where I am known for making arithmetic errors. Not uncommon when you're doing this level of analytical work. It's easy to make arithmetic errors. So I have 4. Let's make this simple. Negative 8 plus 32 is 24. Minus 24. Negative 32 plus 64 is 32. And 4 plus 32 minus 24 is 12. That's what this area is. And that's interesting. This black area here we have found to be 12. 12 units squared. That particular example will help you with number 45 and number 46. If you need to pause the video, go right ahead. If you need to rewind it, that's okay as well. Let's look at our next example here. This is all I'm going to do is set up the problem for number 47. Looking at number 47, you have the handout in front of you. What I want is this shaded area, this purple area. The graph, that black line, is part of the graph of y is equal to 1 plus cosine x. That's this graph right here. I have this constant function y equals 2 here, and I'm stopping everything at the number pi. So this is what I want, that purple area. How do I find that purple area? This is a type of problem that comes up time and time again on AP assessments. Here's the easiest way that I have found to explain this. What I have here, if I look at the purple area, is going to be the yellow area, which is the area of this entire rectangle, the yellow area. And what am I going to do? I'm going to subtract from it the blue area. What's that going to give me? That's going to give me the purple area. So I have the yellow area here, which is a rectangle, and the blue area, interesting enough, can be found using a definite integral. It is the definite integral from 0 to pi of 1 plus cosine x. What is the yellow area? The yellow area is a rectangle. This rectangle has a base of pi and a height of 2. So the area of that rectangle is simply pi times 2. Ladies and gentlemen, I'm going to let you evaluate this definite integral on your own. Keep in mind, I want the the purple area. The purple area is going to be 2 pi minus whatever answer you get from evaluating this definite integral. Keep in mind, boys and girls, friends and neighbors, that area is always positive. So if you end up with a negative answer, you've done something wrong with your analytical work. So let's close this little video out with a setup for number 43. What I want is the area bounded by y equals x cubed minus 3x squared and the x-axis. Heavens to Betsy. Betsy, use your graphing calculator to graph this particular function. And if you see this function, graph it with your graphing calculator. And if you notice, the only area that's bounded by the x-axis is this yellow area here. That's the only area bounded by the x-axis. This area over here, this is unbounded. This area over here is unbounded. I want the area bounded. The other thing I have to point out is I want the area. I don't want the definite integral. I want the area. So if I want the area, I'm going to have to, again, set up two definite integrals. I'm going to have to set up a definite integral that's going to give me that area, and I'm going to have to set up a definite integral that gives me that area. This is, again, a reference to the definite integral practice that I did before Christmas break. So here I go. If I want this first part here, that's going to be simple. All I'm going to do, and I have to notice, by the way, that the zeros of this function are 0, 1, and 2. That's where this particular function crosses the x-axis. Those are the zeros. And it makes it really handy. This problem was carefully written. So what I want to do is find the definite integral that gives me this first piece. What is that definite integral going to be? It's going to be the integral from 0 to 1 of the function x cubed minus 3x squared plus 2. And then here's the interesting part, or the part that a lot of people will slip up on. If I want this area and this function is below the x-axis, and we did a problem like that yesterday, mind you, I can't just take the integral from 1 to 2 of this function, because that would be the definite integral from 1 to 2 of this function. That's going to be negative because this function is below the x-axis from 1 to 2. So to correct that problem, I'm going to take the opposite of this function from 1 to 2. So this is going to be the setup to find the area bounded by the graph of x cubed minus 3x squared plus 2 in quadrant 1. That should be a nice video to get you started on Orange Book 41 through 48. Do not do the other problems, just stick with 41 through 48. Those are some good area problems. Thank you very much, and I will see you soon.